We now discuss the solution of the problem from the section Partial Differential Equations. This question is on Lagrange's first order linear partial differential equation. This question has appeared in CSIR National Eligibility Test held on 16th February 2022 and it is from the section B. The problem is let u is equal to u of x comma y. Solve the Cauchy problem dou u by dou y minus x into dou u by dou x plus u minus 1 is equal to 0, where minus infinity less than x less than infinity y greater than or equal to 0 and u at x comma 0 is equal to sin x. Then u at 0 comma 1 is equal to, we are given 4 options. Option 1, 1 minus 1 by e. Option 2, 1 plus 1 by e. Option 3, 1 minus sin e whole by e. Option 4, 1 plus 1 minus sin e whole by e. And it is given u is a function of x and y. We have to solve this Cauchy's problem. Del u by del y minus x into del u by del x plus u minus 1 is equal to 0, where x belongs to R and y is non-negative. And it is further given u at x comma 0 is equal to sin x is the initial condition. Then we have to find u at 0 comma 1 from the following 3 options. We now discuss the solution of the problem in detail. We have u is a function of 2 independent variables x and y. Given the Cauchy problem, here we are given a first order partial differential equation with a initial condition. That is a special class of Cauchy's problems. And now del u by del y minus x del u by del x plus u minus 1 is equal to 0 with u at x comma 0 is equal to sin x. Now this will be written as x dou u by dou x minus dou u by dou y is equal to u minus 1. Yes. Now this we write it as x p minus q is equal to u minus 1, where p is equal to dou u by dou x and q is equal to dou u by dou y. And this equation is of the form pp plus qq is equal to r, where capital P, capital Q, capital R are functions of x, y and u. And it is a Lagrange's first order linear partial differential equation. And we write down the Cauchy's auxiliary, we write down the Lagrange's auxiliary equations. They are dx by p is equal to dy by q is equal to du by r. And here p is x, q is minus 1, r is u minus 1. That is dx by x is equal to dy by minus 1 is equal to du by u minus 1. We first take the first two ratios. Now dx by x is equal to dy by minus 1 and integral dx by x is equal to integral dy by minus 1 plus ln c1, where c1 is the constant of integration, and that will give rise to ln x plus y, and integral dy by minus 1 is brought to the left hand side and integrated. Ln x plus y is equal to ln c1, and taking out the ln's, we will get c1 is equal to x e power y. X e power y is equal to c1. That's the equation 1 and a solution of the Lagrange's first order linear partial differential equation. We continue in the next slide. That's what we have done so far. A solution is x e power y is equal to c1 for the given first order linear partial differential equation. Let's now take the second and third ratios. That is dy by minus 1 is equal to du by minus 1, du by u minus 1, and integrating, that is integral of dy by minus 1 plus ln c2 is equal to integral of du by u minus 1. After integration, you will get minus y plus ln c2 is equal to ln of u minus 1. And this will give rise to c2 is equal to u minus 1 times e power y. So c2 is equal to u in the brackets u a function of x comma y minus 1 into e power y. Let's call this as the equation 2. We are given u at x comma 0 is equal to sin x, initial condition, and put y is equal to 0 in the first equation, and the second equation we get. When you put in the first equation, you will get c1 is equal to x e power 0. That e power 0 is 1 x. c1 is equal to x, and c2 is equal to u at x comma 0, y is 0, minus 1 only, and e power 0 is 1. So c2 is u at x comma 0 minus 1. But it is given u of x comma 0 is sin x, we write sin x minus 1. c2 is sin x minus 1, c1 is the x, and we get a relationship between c1 and c2 as follows. And c2 is equal to sin x minus 1, but x is c1, we will get c2 is equal to sin c1 minus 1. Therefore, and c2 we write down again u in brackets u at x comma y minus 1 into e power y, this is c2, is equal to sin c1 is x e power y minus 1. So that is the solution of the given first order linear partial differential equation. Now required to find u at 0 comma 1. So in 3, put x is equal to 0 and y is equal to 1. We get u at 0 comma 1 minus 1 into e power y is 1, e power 1 is e, is equal to sin of x, x is 0, sin 0 is 0, and minus 1. So minus 1. So we get this one. And u at 0 comma 1 minus 1 is equal to minus 1 by e. Send this minus 1 to the right hand side. You will get u at 0 comma 1 is 1 minus 1 by e. So that's our answer. And let's look at our options. In these 4 options, our answer 1 minus 1 by e appears against option 1. Therefore, our answer is option 1. So that is the discussion of the solution of the problem from the section Partial Differential Equations, and the question is on Lagrange's first order linear partial differential equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.